A coin just landed on heads 5 times in a row. Quick, what is it going to do next? If a little voice in your head just whispered that tails is due, that it has to even out now, then you have felt the exact reason probability confuses almost everyone. Because that voice is wrong. The coin has no memory. It does not know what it just did, and the next flip is still a perfectly even 50-50. Probability is the one part of math where your gut instinct actively lies to you, and that is precisely why it is worth learning. Once you can see what randomness is really doing, a huge amount of the world stops feeling like luck and starts making sense. So today, we are going to build probability from the ground up in plain language until the parts that fool everyone else feel obvious to you. I am Daniel, and this is Simplex Academy, where we take ideas that usually feel impossible and make them simple from the ground up. And here is the first thing to let go of. Probability is not fortune-telling. It does not predict what will happen. It just measures how likely something is, carefully, with numbers instead of hunches. Let us start with the single idea everything else is built on. At its heart, probability is just counting. To find the chance of something, you count the outcomes you want, and you divide by the total number of outcomes that are possible, as long as each one is equally likely. That is the whole engine. Take a coin. There is one way to get heads, and there are 2 possible outcomes in total. Heads or tails. 1 out of 2. That is 1/2, or 50%. Now take a single die, the kind with 6 faces. What is the chance of rolling a 4? There is 1 4 and 6 faces in total, so the answer is 1 in 6. Favorable outcomes on top, all the possible outcomes on the bottom. If you can count those 2 numbers, you can find a probability. And every probability you will ever calculate lives on one simple scale, from 0 to 1. A probability of 0 means the thing is impossible. It will never happen. A probability of 1 means it is certain. It always happens. And everything interesting lives in between. 1/2 means it is an even toss-up. A probability near 0, like 0.01, means very unlikely but not impossible. A probability near 1, like 0.99, means almost certain but not guaranteed. Sometimes we say these as percentages instead, from 0% to 100%, but it is the exact same scale. So whenever you meet a probability, you can immediately place it. Is this closer to impossible, closer to certain, or somewhere in the messy middle? Now let us go back and fix that lying voice in your head, because this is where most people get lost. It is called independence. 2 events are independent when one has absolutely no effect on the other. A coin flip is the perfect example. The coin does not remember its last flip. Every single toss is a fresh, clean 50-50, no matter what came before. So when 5 heads land in a row and your gut screams that tails is due, your gut is committing what is actually a famous mistake, called the gambler's fallacy. The next flip does not care about history. It is still 1/2. But hold on, you might say, is not 5 heads in a row supposed to be rare? Yes, and here is the subtle part that clears the whole thing up. Getting 5 heads in a row, predicted in advance, from the very start, is genuinely unlikely, about 1 chance in 32. But once 4 heads have already happened, that is over. Those flips are done. The only question left is the single next flip, and that one flip is always 50-50. The small number describes the whole run before it begins. It says nothing special about the next toss once the run is already underway. Hold on to that difference, and the gambler's fallacy loses its grip on you forever. Now, you might reasonably ask, does it not balance out somehow? Do not casinos rely on things evening out over time? Here is the honest answer, and it is genuinely beautiful. Randomness does settle toward the average, but only over enormous numbers of trials, and never by correcting what already happened. Flip a coin 10 times and you might easily get 7 heads, but flip it 10,000 times and the share of heads will be spectacularly close to 1/2. Not because the coin repaired its earlier lopsidedness, but because a handful of extra heads early on gets diluted into an ocean of later flips until it barely shows. The average is not enforced by a memory. It emerges from sheer volume. That idea has a name. The law of large numbers, and it is the quiet engine underneath every insurance company and every casino on Earth. So how did we get that one in 32? That brings us to the rule for combining independent events. When you want the chance of one thing and then another thing, Both happening, you multiply their probabilities. The chance of 2 heads in a row is 1/2 times 1/2, which is 1/4. 3 heads in a row is 1/2 times 1/2 times 1/2, which is 1/8. Keep going 5 times and you land on that one in 32. The same rule works for anything independent. The chance of rolling 2 dice and getting a 6 on both is 1 in 6 times 1 in 6, which is 1 in 36. And notice what multiplying does. Each thing you demand at the same time makes the combined chance smaller because you are asking the world to line up more conditions all at once. There is a second combining rule for a different kind of question. Sometimes you do not want this and that. You want this or that. When you are asking for the chance of one outcome or another, and they cannot both happen at once, you add instead of multiply. On a single die, the chance of rolling a 1 or a 2 is 1 in 6 plus 1 in 6, which is 2 in 6, or 1 in 3. A quick way to keep them straight, and usually means multiply, and the chance goes down, or usually means add, and the chance goes up. Get those 2 words right, and you have avoided one of the most common mistakes in the whole subject. There is also a neat shortcut hiding inside that 0 to 1 scale, and it will save you constantly. The probability that something does not happen is just 1 minus the probability that it does. If the chance of rain is 70%, then the chance of no rain is the remaining 30. This sounds almost too simple to bother with, but it quietly cracks open some of the hardest-looking questions. Suppose you want the chance of getting at least 1/6 when you roll a die 3 times. Going after at least 1 head-on is messy, because it could be exactly 1/6, or 2, or all 3, and you would have to add up every case. But the opposite, getting no 6s at all, is a single clean multiplication. So you find the chance of no 6s, subtract it from 1, and you are done. Whenever a question says at least 1, reach for this flip first. Everything so far assumed the events do not affect each other, but plenty of things do. These are called dependent events, where the first outcome changes the setup for the second. Picture a standard deck of 52 cards, and you want to draw 2 aces in a row. The chance the first card is an ace is 4 aces out of 52 cards. But once you have pulled that ace out and kept it, the deck has changed. Now there are only 3 aces left and only 51 cards. So the second probability is 3 out of 51. The pool shrank. That is the signal of a dependent event. You are not resetting each time, so you have to update your numbers as you go. Let us take a quick breath, because you now have the real core of probability. Count the outcomes, place them on the 0 to 1 scale, multiply 4 and add 4 or, and watch out for whether events depend on each other. If this is finally untangling something that always felt slippery, that is exactly what this channel is for. So consider subscribing to Simplex Academy. Hard topics, explained from zero, without the fluff. Now let me show you the idea that fools even doctors. It is called conditional probability, the chance of something given that you already know something else. And it hides one of the most surprising results in all of math. Imagine a test for a rare disease, and the test is 99% accurate. That sounds almost perfect. So if you test positive, you should be terrified, right? Actually, no, and here is why. Suppose this disease is genuinely rare, affecting about 1 person in 1,000. Now imagine testing 10,000 people. About 10 of them actually have the disease, and the test correctly flags those 10. But the test is also wrong 1% of the time, and 1% of the roughly 10,000 healthy people is about 100 false alarms. So look at what happens. Around 110 people test positive, but only about 10 of them are truly sick. That means if you got a positive result, the chance you actually have the disease is only about 1 in 10, not 99%. The reason this feels impossible is that we forget how rare the disease was to begin with. That starting rarity is called the base rate, and ignoring it is one of the most expensive mistakes people make in medicine, in courtrooms, and in everyday judgments. The lesson of conditional probability is simple to say and hard to feel. How likely something was before the new evidence matters just as much as the evidence itself. A very accurate test for a very rare thing still produces mostly false alarms. There is one more idea that turns probability from describing chances into making decisions, and it is called expected value. Expected value is the long-run average of something random if you repeated it a huge number of times. Take a fair die. Its faces are 1 through 6. If you roll it thousands of times and average all the results, you land on 3.5, right in the middle. even though you can never actually roll a 3.5. That average is the expected value. And this idea is exactly how casinos and lotteries are designed. Every bet is set up so that its expected value is slightly in the house's favor. You might win once, you might win twice, but averaged over millions of plays, the math quietly guarantees the house comes out ahead. A lottery ticket is the same story wearing a friendlier face. It might cost you $1, but when you add up the tiny chance of each prize multiplied by what that prize pays, the expected value usually comes out to only 50 or 60 cents. You are handing over $1 for something worth less than $1 every single time you play, which is why a lottery is sometimes called a tax on not understanding probability. When you understand expected value, you stop asking, could I win, and start asking, what happens on average, which is the question that actually protects your money. Now let me connect this to something you might have already watched. If you have seen our video on statistics, here is how the two fit together. Statistics looks backward at data you already have and describes it. Probability looks forward and predicts the data you are likely to get. One studies the results after the dice are thrown. The other tells you what to expect before you throw them. They are two directions on the same road, which is why they are almost always taught as a pair. So where does all of this actually show up? Everywhere decisions meet uncertainty. Every weather forecast is a probability, which is why it says a 70% chance of rain, not a promise. Insurance is entirely built on it, quietly calculating the odds of accidents to set your price. Doctors weigh probabilities to decide on tests and treatments. The spam filter on your email is guessing the probability that a message is junk. The recommendations you get, the games you play, the medical studies you read about, all of it runs on the ideas you just learned. Probability is the mathematics of living in a world you cannot perfectly predict. Before we wrap up, let me save you from the mistakes that trip up almost everyone. First, and biggest, the gambler's fallacy. Random events do not even out in the short run, and a coin is never due for anything. Second, ignoring the base rate. How rare something was to begin with can completely flip what a piece of evidence means, just like that medical test. Third, mixing up and with or, and means multiply and the odds shrink, or means add and the odds grow. Fourth, assuming events are independent when they actually depend on each other, like forgetting the deck changes after you draw a card. And fifth, confusing unlikely with impossible. Rare things absolutely do happen, especially when there are millions of chances for them to. A 1 in a million event is nearly guaranteed to happen to someone, somewhere, today. So let us bring it home. Probability is not fortune-telling. It is careful counting. It is favorable outcomes over total outcomes, placed on a scale from 0 to 1. You multiply 4 and you add 4, or you watch whether events depend on each other, and you never forget the base rate. Expected value tells you the long-run average, and it is why the house always wins. And through all of it, remember the one lesson your gut keeps getting wrong. Randomness has no memory, and no result is ever owed to you. Once you truly believe that, you are not just doing probability, you are seeing the world more clearly than most people ever will. So tell me down in the comments, what part of probability has always felt the most impossible to you? The gambler's fallacy, the medical test surprise, or something else? And I might rebuild it from zero in a future video. And if this finally made probability click, subscribe to Simplex Academy. I am Daniel, thanks for watching, and I will see you in the next one.